Welcome to Maths with EJD. In this video, I'm taking another non-parametric test, which is called the Kruskal-Wallis Test. The Kruskal-Wallis Test is a non-parametric method for testing whether samples originate from the same distribution. From the same distribution. It is used as an extension of the Mann-Whitney U-test. Remember the Mann-Whitney U-test, we were testing for two variables. Of the Mann-Whitney U-test, comparing three or more independent groups, two or more independent groups. You know that the Mann-Whitney U-test could only handle two groups, but Kruskal-Wallis can handle three or more independent groups. Very important to know. Of course, at this point, you want to subscribe if you have not done that already, and hit the notification bell so you can always get alerted when a new video is released. So back to the Kruskal-Wallis test, right? The test does not assume a normal distribution. Does not assume a normal distribution of the data, making it suitable, making it a suitable alternative, making it a suitable alternative to one-way ANOVA when the assumptions of ANOVA are not met. Okay, I've not done any video on ANOVA. I'll do it in a future video. That will be treated separately. But of course, we've done Mann-Whitney U-test for two variables, but then Kruskal-Wallis can handle three or more independent groups. So here, what are the hypotheses for Kruskal-Wallis? Let's go for that. So the hypothesis the null hypothesis, first of all, the null hypothesis, H naught. So it says that the distribution of the dependent variable is the same across all groups. So it's the same across all groups. Okay. And then of course we have the alternative hypothesis, which is HA or H1 as you like. Alternative hypothesis, that is HA. So that'll be the opposite, right? Here it says at least one group's distribution, is different from the others. Okay. Now we talk about the test statistic for the Kruskal-Wallis test. the test statistic. That's like a key part of this, of every test, in fact. The test statistic is always important because at the end of the day, for us to make a decision, we compare the test statistic with the critical value obtained from the relevant table to each test. So the Kruskal-Wallis test compares the mean ranks, of the groups. So the test statistic H is calculated using this nice formula. H equals 12 over n into n plus 1, summation from I equals 1 to k of ri squared divided by ni minus 3 into n plus 1. So if you can say it looks a bit like the Mann-Whitney test statistic, except that now it's a bit modified to accommodate as many groups as possible that you may want to consider. So what are these things now? K, for instance, is the number of groups. So if you're considering 3 groups, your K is 3. Number of groups, K. Then N is the total number of observation. Total number of observations. So you know each group has a number of observations. So total number of observations is sum of all the observations across the groups. Then you have Ni. Ni is the number of observations in the ith group. Number of observations in the ith group. That means that if you're talking about the first group, that's N1. So that will, N1 will be number of observations in the first group. Then we have Ri. Ri is the sum of ranks of the ith group. So that's sum of ranks of the ith group. That is Ri. Okay. So with that, let's talk about the decision rule. What's the decision rule for Kruskal-Wallis test? Decision rule. So the test statistic H approximately follows a chi-square distribution. Interestingly, the next video after this is the chi-square test. So it approximately follows a chi-square distribution with k minus 1 degrees of freedom. It's k minus 1 degrees of freedom. So we compare H to a critical value, from the chi-square distribution, or use a p-value. So, and the decision rule is such that first, if H, that's a test statistic, H is greater than the critical value, or p-value, okay, if H is greater than the critical value or p-value is less than alpha, right? Alpha, of course, is the significance level. So if it is the critical value you're getting, then you compare that with H. If it is p-value, you compare that with alpha. So if the test statistic H is greater than the critical value or the p-value is less than the significance level, In that case, you reject H naught, Then secondly, if H is less than or equal to the critical value, if H is less than or equal to the critical value, or the p-value is greater than or equal to alpha, then you accept the H naught, or what you say is fail to reject. You fail to reject H naught. So that's the decision rule. Now let's go ahead and talk about a specific example. So we have an example now, and the focus of the example is to analyze. It's about analyzing reaction time, for three age groups. So that's the beauty of Kruskal-Wallis. You can do more than two groups. Analyzing reaction time for three age groups, right? So suppose we want to compare the reaction times of individuals from three different age groups. Okay, we have the young, that is group 1. We have middle-aged, which is group 2. And we have the elderly, which is group 3. So we want to test if the distribution of reaction times is the same across these groups. Okay. So the first thing we want to talk about, let's state the hypothesis. Okay. So from what we want to test, right? That determines the hypothesis. So we want to test if the distribution of reaction times is the same across these groups. So we can start with the hypothesis. Two hypotheses. So first we have H naught. H naught is that the distribution of reaction times, the distribution of reaction times is the same across the groups. So let's call that step 1. So the distribution of reaction time is the same across the groups. So the alternative hypothesis will just be that there is at least one distribution with there's at least one distribution, or let me say there's at least one group, with a different distribution, okay? With a different distribution. So that's the alternative hypothesis. And then we move on to second step. Second step will be to collect data. So let's talk about data collection. So for the data collection, right? Let's say uh the reaction, the reaction times, the reaction times in milliseconds. That's I think one over 1,000 of a second, I believe. In milliseconds for the groups are first group one, the young group. The reaction times are 180 milliseconds, 200 milliseconds, 210 milliseconds, 220 milliseconds, and 230 milliseconds. That's group one, the young. Then group two for the middle aged. The reaction times are 250, 270, 290, 310, and 330. Okay. Then group three, we have the elderly. We have the elderly, and the reaction times are 350 milliseconds, 370 milliseconds, 390 milliseconds, 410 milliseconds, and 430 milliseconds. So that's step two, and then we go for step three. Okay, I've not been using a step, it's just the number. So number three now, we want to rank the data, Okay, so we can consider ranking even from before we even come here, right? This is, okay, let's just do this. So we want to rank the data. So we are ranking across all the groups. So the smallest is 180, that's 1, 2, 3. Oh, interesting, everything follows. But it doesn't have to follow, right? It doesn't really have to follow. But whether it follows or not, just rank according to the order. So I don't think we even have to stress ourselves because it's already ranked. We just need to know the total number. That's one. So there's no point because everything follows. Uh, there's nothing mixed up anyway. Everything is in order. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 all together. So let's do this. Let's go ahead and put that in a table. So we have the value, that's the reaction time, value, group. Okay, since we said reaction time, right, I think it's appropriate to just say reaction time so that we are not in doubt of what the value is about. Reaction time, okay, group, the group that belongs to, and the rank. Thankfully, everything is somehow ordered, even from the original list. So it's very easy to follow. So we have 180. 180 belongs to the young group, that's group one, and that takes position one. 200 follows, group one, rank two. 210 follows, group one, rank three. Then 220 follows, group one, rank four. Then 230 follows, 230, group one, rank five. Then that's all from group one. So for group one, right, we can even put that by the side that N1 is equal to 5. That's the number of collections from group one. So because that information is going to be useful later. Then we have 250. 250 is coming from group two. 250, group two, rank 6. So we rank everything across, but just like for the Whitney U test. Then after 250, we have 270. It is from group two. It is ranked number 7. Then we have 290. It's from group two, ranked 8. Then we have 310. It's ranked 2. It's from group two, ranked 9. And then there's 330. 330. It is group two, ranked number 10. And then we have 350. We have 350. It's in group two, ranked 11. Then we have 370. Oh, so 350 is in group 3. Sorry. 350 is in group 3. It's in group 3. So we can talk about N2 now. We know N2 is 1, 2, 3, 4, 5 also. 1, 2, 3, 4, 5. So each one is 5 actually. So nice. They don't have to be the same actually. So N2 is 5, like N1 is. Oh, okay. I think that I've covered more than necessary. N2 is N2 is actually 1, 2, 3, 4, 5. 1, 2, 3. Yeah. N2 is 5. N2 is 5. And then we go for for the group 3. 37, 350 is in group 3 and it's number 11. Then 370 is group 3 and it's number 12. 390 is in group 3 and it is ranked 13. Then we have 410. Okay, there's 410 in group 3, it's ranked 14. And lastly, we have 430, it's ranked 3, and it is number 15. So again, N3, the number of samples in group 3 is also 5. So it's 5 in each group. So we go ahead now to do the next step. That should be step 4. Yeah, step 4 now. Step 4, since we now have the data, so we calculate rank sums, calculate rank sums for each group. So, and that's made really easy. So for group 1, which is for the young, it's such that rank 1 is equal to, it's 1, 2, 3, 4, 5. So that's pretty easy. We have 1 plus 2. I mean, if it is scattered, then you have to really be careful with that. But this one is really straightforward, so we can do this. So adding 1 to 5 is 5 times 6, 30 divided by 2, that's 15. Then if you go for the next group, that's group 3. I mean, group 2, the middle-aged. So we have R2. That will simply be 6 plus 7 plus 8 plus 9 plus 10. That's like 55 minus 15. That should be 40. Add from 1 to 10, that's 55 minus 15, that's 40. Then, or 6 plus 7, 13. 13 plus 8 is 21. 21 plus 9 is 30. 30 plus 10 is 40. So that's another way to do it. So group 3 is about the elderly. And R3, don't forget the R's are, the R, what's the meaning of the R again? Okay, it's a long way of, that's the sum of ranks of each group, of the ith group. So R1 is sum of rank for first group. R3 is sum of ranks for the third group. And thankfully, everything follows. So you have 11 plus 12, that's 30. Okay, 11 plus 12 plus 13 plus 14 plus 15, and that is equal to 23, 36, 50 plus 15, 65. That's 65 for the third group. So that's the fourth step. Then we go to the fifth step. The fifth step is to compute the Kruskal-Wallis test statistic. Compute the Kruskal-Wallis test statistic H. That's the fifth step. So we have to remember the formula again, right? The formula H is equal to 12 over n into n plus 1 summation from I equals 1 to k of R1 squared divided by n I minus 3 into n plus 1. So we have to plug in the formulas now. And to do that, we have H equals 12 over the total number, right? We have to do that by the side. So n total n is actually n1 plus n2 plus n3, which is 5 plus 5 plus 5, and n is 15. Okay, so that means we have 12 over 15 into 15. Okay, yes, I'll change that. So 12 over 12, 12 over 15 into 15 plus 1. And summation means, so for Ri, R1, right? So, okay, let me really make it simpler, right? Let me make it simpler. Let me break down the formula first to make it clearer. So you have 12 over n into n plus 1. Summation of Ri squared over Ni simply means that we're going to have, since we know that I is from 1 to k, there are three groups. So it means we have R1 squared over N1 plus R2 squared over N2 plus R3 squared over N3. That's simply what this part means. And minus 3 into n plus 1. That's how to break it down. So if you have like four groups, you just extend that to 4, basically. So again, let me just list out these things. Big N is 15 because we have 5, 5, 5 across three groups. That's 15. Then we have R1. R1, from what we just did, R1, R2, R3, 15, 40, 65. So 15, R2 is 40, and R3 is 65. Then we have N1 is equal to N2 is equal to N3, and that is 5 each. So that's easy peasy. Then we can have H to be 12 over 15 into 15 plus 1. That's multiplied by R1, that's 15 squared. 15 squared divided by 5 plus 40 squared divided by 5 plus 65 squared divided by 5. Then minus 3 into 15 plus 1. So H is 12 over 15 into 16 into 15 squared divided by 5. That's 225 divided by 5. That's simply 45. Yeah. Then 40 times 40 divided by 5. That is like 8 times 40. That's 320. 320. Then 65 times 65 divided by 5. That's 13 times 65. Should be 845 minus 3 into 16. That's 15 plus 1. And we try to tidy things up. H is equal to 12 over 15 times 60. How do we make this easy? If you bring 2 from 16, that's 30 times 8. That's 240. 240 into 45 plus 320 plus 845 is actually 1210. 1210. All of that, this is multiplication now. All of that minus 48. So H is equal to K. If you 0 cancel 0, right? So 12 times 1 to 1 divided by 24, I believe that should be 60.5. You can check that to be very sure. If it's not correct, just make sure you write the correct thing. Well, I think that's what this should be. 60.5 divided by 48, minus 48 now is 12.5. So this is our test statistic. H equals 12.5. So the next thing we want to do is to determine the critical value. That's the next thing. That should be our sixth step. So sixth step now is to determine the critical value. So of course that should come from a table. So for a significance level of alpha equals 0.05 and k minus 1, which is equal to 3 minus 1, No, there are three groups. That's the K here now. So that's 3 minus 1 equals 2. So at the significance level of alpha equals 0.05 and degree and 2 degrees of freedom the critical value from the chi-square distribution, the critical value from the chi-square distribution table is approximately 5.991. Okay, so with that, we can now so we have 5.991, right? Yeah, that's that. Then that's a step 6. Let's go to step 7. So step 7 is to make a decision since we have both the test statistic and the critical value. So we have to make a decision. Make a decision. So already we know the H test, that's the test statistic, is actually 12.5. And we have the H critical, if you like, and that is 5.991. And do that properly. 5.991. Okay. So we say since the test statistic, since H test, that is greater, right? Is greater than, okay, let me yeah, you can see the values already. So since the test statistic H test is greater than H critical, that's the value from the table, then the condition is that once the test is greater than the critical, we reject the null hypothesis. So we reject the null hypothesis. We reject the null hypothesis. So alternatively, we could compute the p-value, which would be less than 0.05, leading to the same conclusion. So what is the final decision? What do we say finally about the setting we started with? Because at the end of the day, you want to be able to make a decision in the context in which you are functioning. So the Kruskal-Wallis test indicates that there is a statistically significant difference in the reaction times between the three age groups. Therefore, we reject the null hypothesis and conclude that at least one group's distribution of reaction times is different from the others. Well, if you now want to know which group is different, that's where things like post hoc test comes in. I don't know if I'll be able to get to that point though. Let's see. So we see that this example demonstrates how to use the Kruskal-Wallis test to analyze whether three or more independent groups differ significantly in their distribution of a continuous variable. That's been an interesting one. If you have not subscribed to this channel, be sure to do that. Hit the notification bell also so you can always get alerted when a new video is released. And don't forget to comment. Let me know if you want me to teach a particular topic or you want me to solve a question, and like also and share so that more people can have access to this great learning. Till I see you again, keep learning.